The block diagram of the car park system. There are two inputs here. The first is from the sensor 1, which will detect the car that enters the parking lot. The second one is from the sensor 2, which will detect the vehicle that exits the parking lot. The microcontroller that manages all logic taking input from the sensor and controlling the output is ARM Cortex M4. There are two outputs here. The first is the green LED. It will turn on when the parking is available and turn off when the parking lot is full. The second output is 77 display. It will display the number of vacant parking space. When the parking lot is full, it cycles through the FULL, which is full.
The diagram shows the circuit connection of car system using STM32F401CC06 as microcontroller. For input, we have two active high push button represent sensor 1 which detects cars coming in and sensor 2 which detects cars coming out. Sensor 1 will be connected to PB0 and sensor 2 will be connected to PB1. Both push button will be connected to VCC or VDD at pin 24 here. Both push button will not require external resistor since our pull-down resistor will be enabled internally using coding. For output, we have common anode 77 display, so the common terminal will be connected to VCC and the rest A until G terminal will be connected to PA0 and until PA6 respectively. For LED, we have an active low LED, so the anode will be connected to VCC and the cathode will be connected to PB10. For both 77 display and LED, we will connect in series with a resistor to limit the current that will pass through it, so we don't damage our components.
This is the hardware setup for our group assignment. This is the black pill. This is STM32 and this is the LED with resistor, push button and 77 display with resistor as well. This one is set to active low, so we set to VCC for positive side. For button as well, we set to VCC to make it active high, and lastly, the 77 display we set to VCC to make it as common anode.
For the main function of the flowchart, the system is starting by initializing GPIO pins and setting the car counter to 0. It is continuously read the sensor 1, which represent the car entry, and sensor 2, which represent the car exit. If sensor 1 is pressed, the car count will be increased by 1. If the sensor 2 is pressed, the car count will be decreased by 1. After updating the count, it calls the update display subroutine. So on here we got three parts of subroutine. For the first part, it's used to create a delay in milliseconds, and it's used a log to count up the specific time, ensuring proper timing for button debouncing and display updates. For the second part, it's used to configure the GPIO pins. It set PB0 and PB1 as input for the sensors and PB10 as output for the green LED, and it is configure port A for the 7-segment display and enable put down resistor for the buttons. For the third part, is used for update the 7-segment displays. If the parking lot is full, means the car count is greater than 9, it will display full by cycling through each alphabet FULL with a 500 millisecond delay. And if parking is available, it displays the number of vacant space using a predefined segment display array.
Code as we are using the board STM32F401CCU6, so we're using the library, include the library of STM32F4XX.h. Then we define the function needed for the project, which is delay ms, GPIO, init update display, and the car count equals to 0, and the 77 display common anode configuration, which represents the bit 0 to 9 when the code will light up the LED when it needed lah. So we go into the main code and we call out the function GPIO to configure the pin. Then we go to the line while 1. So if the entry button is pressed, the car count will added by 1 and update the vehicle space and update the display of 7 segment. and then when the exit button is pressed, the car count will minus by 1, and then it also will update the vector space or display full when it's full. So if car count is less than 10, the LED will be turned on, and when it's more, the car count is more than 10, if the more than 9, so the LED will be turned off, which means the car park is full. So we enable the clock for GPIO A and GPIO B, then configure port B, PB0, PB1 as input and PB10 as output for this clock, and then we enable pull down resistor for buttons. Then we configure port A, which is our output. So we configure GPIO A model 5555 to let every pin to be output. Then the function of update display, so if the value is more than 1, means that the car count is equals to 9. So if the display full, which is this code, okay, so else if this is not full, it will show the vacant space, and the delay MS is used to debounce the button, and that's all for the coding.
Okay, for the hardware verification, for first, the 7-segment display will display the all high, and this is the counter for +1, count up, this one is countdown, and this is a LED bulb to show whether there is vacant space. So first, when there's a car enter, so we press 1, it will start, and the LED will display 9, as there's still 9 vacant space. And okay, count up, 8, 7, 6, 5, 4, 3, 2, 1. So there's one space more left, and when it's full, it will display FULL, full. Then this one will vanish. Okay, and when there's car out, it will count. There's car out. It will count out again, become 1, and so on, and the bulb will lights up again. Okay, that's all. Thank you.